Good afternoon, class. My name is Robert Langley. I will be talking to you about Cheatham Dam in Middle Tennessee today. We will look at the impacts of dams on fisheries resources in the Cumberland River system, specifically around Cheatham Dam in Middle Tennessee. I selected this area because much of my coursework and personal interests focus on fisheries conservation, adaptive management, and habitat management in Tennessee waterways. The Cumberland River system is also directly connected to my long-term career interest in fisheries and wildlife conservation management with the Tennessee Wildlife Resource Agency. Cheatham Dam is operated by the U.S. Army Corps of Engineers and serves several purposes, including flood control, navigation, hydropower support, and recreation. While dams provide important economic and public benefit, they also create major impacts on rivers, ecosystems, and fish populations. One of the biggest impacts dams have on fisheries resources is the disruption of natural river flow. Rivers naturally experience seasonal flow changes that help trigger fish spawning, migration, and feeding behavior. Dams alter those flow patterns and can significantly change water temperature, dissolved oxygen levels, and sediment transport both upstream and downstream. Dams create barriers that restrict fish movement and reduce connectivity throughout the river system. Several fish species in the Cumberland River are affected by these changes made by the dam. This includes the skipjack herring, or Alyssa chrysochoris, paddlefish, or Polydon spathura, sauger, or Sanders candinensis, and striped bass, or Morono saxatilis. Many of these fish rely on seasonal movement throughout the river system for spawning and feeding. When dams interrupt migration routes, populations can decline over time. Other major issues is habitat alteration. Reservoirs creation behind dams can flood natural river habitats, while downstream sections may experience reduced sediment movement and habitat simplification. Changes in water flow can also affect aquatic vegetation, nutrient cycling, and food availability throughout the ecosystem. One thing I learned while researching this topic is how complex fisheries management becomes when balancing environmental conservation with human needs like hydropower, flood control, navigation, and recreation. Dams are unlikely to disappear completely, so fishery managers often focus on mitigation strategies instead. These strategies may include fish ladders, controlled water release that mimic natural flow regimens, habitat restoration, and adaptive management approaches. I also learned that ecosystem connectivity is one of the most important concepts in fisheries conservation. Healthy river systems depend heavily on allowing fish and nutrients to move naturally throughout the watershed. Once that connectivity is disrupted, impacts can spread throughout the entire ecosystem. This topic has reinforced how important long-term science-based fisheries management is when dealing with habitat modification and river system changes. Fisheries conservation involves much more than simply managing fish populations. It also requires protecting habitat quality, water conditions, and ecosystem function over time. Thank you for your time.